And today we are learning real-world problems in algebraic expressions. Our objective is I can solve real-world problems involving algebraic expressions. Looking at number 1, it says Miss Davis had X dollars. She bought a dress for $35 and spent the rest of her money on 3 identical notebooks. It's important to highlight all the key details when we are working with algebraic expressions and real-world problems. So we are going to highlight Mrs. Davis had X books because that is an important key detail. We're also going to highlight that she bought a dress for $35. And we're also going to highlight she spent the rest of her money on 3 identical books. So those are all the key details that we are going to highlight. Looking at part A, it says find the price of one notebook in terms of X. Well, we know, we're going to make a little diagram so that it makes it a little bit easier for us. So if we had, make a diagram for us. So if we know that she bought 3 identical books and then one dress for $35. And these represents our books. I'm going to write a B and an O for books. So we want to try and find out how much the price of one notebook cost. And we do not know how much money she started with. So this is how much, this is X, the amount of dollars that she had. So how we are going to solve this is that we know that the price of 3 notebooks is X minus 35 because however much money she had left over, which was X, is how much she spent on her books. So then in order to find out how much she bought in terms of all 3 books, we need to find how much she bought for one book. We're going to take X minus 35 and we need to divide it by 3, and that will tell us how much she bought for one book. So this would be our answer for part A. It is always important to remember that when we have a term with an unknown quantity, for instance, and right here, so X is our X minus 35 and divided by 3 is a term, and when our unknown quantity, which right here is X, that it'll always be represented by a variable. So X is our variable in this part A. It's always important to remember that it'll always be represented by a variable when there is an unknown quantity. All right, looking at part B, it says if Miss Davis had $50, so now we know how much Miss Davis had. She had $50. What's the price of one notebook? Well, we know that X now equals 50, and we solved in part A what one notebook would cost, so it was X minus 35 divided by 3. Now we know the value of our variable, so we can substitute it in. So now we have 50 minus 35 divided by 3, and we can subtract 50 from 35, which gives us 15, divided by 3 gives us 5. So it cost her $5 for one notebook, and that's our answer for part B. Looking at number 2, it says Mr. Peterson had Y dollars in his wallet at first. After withdrawing $30 from the bank, he gave his wife half of the total amount that he had. So we got to highlight all the key details that we have found. So we know Mr. Peterson started with Y dollars in his wallet, and then he went and withdrawn $30 from his bank. So he gained $300. But then he gave half of his money to his wife. So those are all of our key details that we need to highlight. In part A, it says find the total amount of money that he had in terms of Y. So we were trying to figure out how much money he had in terms of Y. So looking at this, we know that Y represents how much money he started with. So this is how much money how many dollars he started with. So we're going to write Mr. P next to it. But then he went to the bank and he withdrew an additional $300. So now we have to add $300 because now this is also what Mr. P has. But then he went and gave his wife half of his money that he made. So we're going to split this in half. So we're going to make a fraction half, and we're going to write a W because he gave that to his wife. Now we can, with all the information we have found, we know Mr. Peterson started with Y dollars. He added $300 because he withdrew $300 from his bank account. And then whatever money he had in total, he went and gave his wife half of it. So we have to divide by 2. And this would be our final answer. And remember, you always want to keep in mind when we have a term, so this is our term, and there's an unknown quantity, which right here it is Y, it'll always be represented by a variable. So Y is our variable in part A. Looking at part B, it says, if Mr. Peterson had $60 in his wallet at first, how much money did he have left? So if he had $60 in his wallet, and we're trying to figure out how much money did he have left after he gave his wife half. Well, now we know what Y equals. Y equals 60. And we solved in part A our algebraic expression. So now we know Y plus 300 divided by 2. We can substitute our value of our variable in. So now we have 60 plus 300 divided by 2. And 60 plus 300 equals 360 divided by 2. And 360 divided by 2 equals $180. So he had $180 after he gave his wife half of his profit. And that's our answer for part B. Looking at our practice problem, it says ribbon A is K meters long. Ribbon B is twice as long as ribbon A. Ribbon C is 1 meter shorter than ribbon B. So remember, we have to highlight all of our key details. So we know ribbon A, we're going to highlight, was K meters long. And we know ribbon B was twice as long as ribbon A. And ribbon C was 1 meter shorter than ribbon B. This is a lot of information. Looking at part A, it says, find the length of ribbon C in terms of K. So we are going to write this out. So if we know that ribbon A, so we're going to write ribbon A equals K. We know that ribbon B equals whatever ribbon A is, so K, 2 times that. So 2 times K, because it's twice as long as ribbon A. And ribbon C is 1 less than ribbon B. So it is 2K, and it's 1 less than 2K. So this would be our final answer for part A. Looking at part B, it says if K equals 3, how long is ribbon C? Well, we figured out what ribbon C was for our algebraic expression. So we said it was 2K minus 1. We now know the value of our variable, so K equals 3. So we can substitute our value in. So now we get 2 times 3 minus 1. We can multiply 2 times 3, gives us 6, minus 1 equals 5. So ribbon C was 5 meters long. Lastly, looking at our last practice problem, it says Amanda, Bruno, and Carla collected bottle caps for charity. Amanda collected 4F minus 3 bottle caps. Bruno collected twice as many bottle caps as Amanda. And Carla collected 3 times 5 plus 2F bottle caps. So again, we want to highlight all the key details. So we know that Amanda collected 4F minus 3 bottle caps. And Bruno collected twice as many bottle caps as Amanda did. And Carla collected 3 times as many collected 3 times 5 plus 2F bottle caps. So looking at part A, it says find how many bottle caps did they collect altogether in terms of F. So this is a lot. So we're going to take this into two parts. So first we're going to look at Carla because Carla isn't being multiplied or added to anyone else's. So we have 3 parentheses f or 5 plus 2f. We got to multiply we got to take our outside expression and multiply each term on the outside by it. So now we have 3 times 5 gives us 15, and 3 times 2f gives us 6f. And then we have to look at our next part. It said Amanda collected 4f minus 1. So that's how many Amanda collected. 4f minus 3 bottle caps. And then Bruno collected twice as many bottle caps. So what we have to do is that we have to multiply Amanda's by 3 because Amanda collected this amount and Bruno collected twice that amount. So now we have, when we add those together, we get 3. So now let's do the same exact thing. Take our outside expression, multiply each term on the inside by it. So now we get 3 times 4 equals a positive 12f. And then 3 times negative 3 gives us a negative 9. And now this looks like we can simplify. We can add like terms, subtract like terms. So we're going to highlight our like terms. We have 15 is a like term to negative 9. And we have positive 6f is a like term to positive 12f. So now that we know this information, we can add or subtract their like terms from one another. So we're going to start with 15 and negative 9, which 15 minus 9 gives us 6. And then we have 6f plus 12f, which when we add those together, we get 18f. And since they were both positive, our final answer would be 6 plus 18f. And that's our final answer for part A. So remember that when we have a term with an unknown variable, which in this term it is f, that it will always be represented by a variable.